Well, good morning, everybody. Can all hear me, I'm assuming? Good. We're all awake, even though you were out on the town partying all night, is what I hear from the police reports. Well, what I'm going to try to do real quickly is dance slightly across the tip of the grass plants or the tippy top of the icebergs and give you guys some sense of some of the science that we and others are working on. Hello, Steve. That seat with the blue jacket there's available. Some of the science that we and others are working on that's really beginning to document the absolute importance of getting this right, this agricultural conversion on both row crop land and in grazing lands, getting this right because there's so much at stake and there's so many benefits to getting this right. So I think what you'll see here in my presentation is a weaving together or an attempt to weave together some science findings with some lessons learned. So I don't know if there's Q&A opportunities here, Laura, but I'll quickly go through this and I'll cut it quick. Okay. So the first thing that I'll talk about is grazing, and this is part or from a presentation we had the honor of doing at the Obama White House, the Office of Science and Technology, where a group of us, Dr. Richard Teague, is there a way to cut the lights up here? I think it would make the slides easier for people to see. Dr. Richard Teague at Texas A&M, a whole group of researchers from Arizona State University, different ag extension services, other universities, have all combined to form a global team that's looking at improved grazing benefits as a strategy to mitigate climate risks. And I won't report the details, but we're working on a project right now that's 100 million acres in size. So it's the size of 2 Nebraskas, and working with over 4,000 ranchers now in the U.S. and ranchers in Australia, New Zealand, and South America and elsewhere. There's about 3.5 billion hectares of grasslands that are pastured on the planet. Our working hypothesis as researchers is that carbon-rich soil is healthy and it's beneficial for the entire ecosystem and planet, and everything we're doing is testing that. And what was really interesting is Shell Oil Company's internal investment group called the Game Changer Group that invests in all sorts of innovation is the party that sponsored the project that I'm going to talk about. They were realizing that to be responsible as an oil company, if that is an oxymoron, I apologize. Yeah. But we'll start with the premise that they were legitimately, earnestly trying to figure out, and they still are, how to be responsible. We figured out that the excessive 4 gigatons of atmospheric emissions of the approximate 9 every year, the excessive 4 gigatons that stays in the atmosphere, if we could improve soil organic carbon by 1% from approximately 100 tons per acre to 101 tons per acre, that would offset, because there's 3.5 billion hectares of pastures, grasslands, and 1 billion hectares of industrial or row crop ag land on the planet. The potential was really high in a back of the envelope calculation that we could really begin to offset that 4 gigatons of excessive emissions. And more importantly, we could begin to really take down legacy emissions already in the atmosphere. So this was of great interest to an oil company that has 100 million tons of emissions annually that they're trying to figure out how to responsibly address if they're going to exist in the future. So what does cover provide for a landscape? It provides everything. It's the foundation of the economy. It's the foundation of the energy cycle, the water cycle, the nutrient cycle. This is the exact same piece of land, 5 years lapse time. The only thing that changed was 5 times the stocking rate of cattle was put on the image you see on the left, and a very long recovery period was allowed to be introduced into the rotation annually. So a crusted desert pavement in northern Mexico, the only thing that was added was cattle and recovery, period, which is really, really a different way to think about managing highly degraded lands. What happened with this system, it's all documented in publications, the heavy continuous grazed, overgrazed condition on the left was a water generator. All the water, all the rainfall that fell on the land ran off, very little infiltrated, very little supported plant life, and you can see there's very little plant life. The soil crusted over, there was little or no food for cattle, and simply by putting cattle on there to break the crust up and stimulate the seed bank that was present in the soil, the native plant species in this particular location, all warm season grasses, came up and have flourished. And instead of water running off and CO2 being emitted because of organic carbon, soil organic matter decomposition, the opposite, the exact opposite occurred. So the goal of a project funded by Shell was to begin looking at, what does it take to standardize what we're calling adaptive multi-paddock grazing, which is very high density, very short rotation grazing with long recovery periods. This is some of the grazing. If you haven't seen the Peter Bick movies, he's part of our team. Soil Carbon Cowboys and a whole series of the movies. This is that sort of grazing where it's a day to 4 days maximum on a paddock, or less than a day in some projects, some ranches, and then the cattle are moved on and they're moved on, and there might be a 45-day recovery period in the southeastern U.S. There might be a 90-day recovery period in the Great Plains, and in Alberta, which I'm going to talk about now, it might simply be a once-over during the growing season and then a once-over during the winter. So they leave 50% of the forage base on for winter forage. So this particular project, we worked in the 4 primary eco-regional provinces of Alberta, and basically what we did in comparing adaptive multi-paddock grazed ranches that have been grazed for about 10 years minimum using that technique with continuously grazed, heavy and lightly stocked continuous grazed, we went out and measured the soil organic carbon stocks down to 1 meter in depth. We did carbon-13 isotope pulsing that allowed us in real time to follow the fate. How was CO2 being sequestered? Where was that CO2 ending up? Where was the nitrogen oxide and the methane coming from that was outgassing from the soil or from the cattle that were grazing in real time? We also did infiltration measurements with standardized automated infiltrometers that measure actually how quickly water gets into the soil and how much gets into the soil. Not one of those perk tests that you do for siting a trailer or a house. This is a piece of equipment that pre-soaks, does a standard saturation, 100% saturation of the soil column, and then measures infiltration. So it's a very different approach than a perk test. What we learned is that every one of these water cycles, or every one of these functional cycles, energy, water, mineral, and community dynamics, is completely revitalized as was measured. And I'll just give you a few tips of the iceberg reports out on what we learned. Completely restored or on the trajectory toward restoration under continuous grass, especially native grass, and I'll talk about that in a minute. Well, we've learned that the adaptive multi-paddock grazed areas were packing about 1.5 to 2.5 tons of carbon per hectare per year above and beyond what the continuous grazed and whether it was heavy or light stock, continuous grazed paddocks were plowing into the ground, putting into the ground. Hopefully you can see a difference. There's a 10-year period between these two images. Same family, one fence line, 2 brothers. One brother said, screw it, I'm going to do what Dad always did, continue heavy grazing. And that, hopefully you can see that if you were to guess, I'll tell you, It's the image on the left that was continuous graze for over 100 years. The image on the right, a 10-year shift to adaptive multi-paddock grazing with a 3-fold increase in carrying capacity. I mean, just intentionally 3 times the number of cattle. So what was intriguing to me was how quickly the water cycle responds. It takes a while for the plant diversity, insect diversity, microbial and fungal diversity to come back, but the hydrology responds almost immediately within about 3 years is what we're learning. Even in a very high permeability sandy loam soil, measuring a centimeter, more than a centimeter per hour of additional infiltration in a 100% saturated soil system was remarkable to me. But measuring 27 centimeters per hour in a 10 to the minus 8, 10 to the minus 9 centimeter per second clay, highly impermeable clay, blew my mind to see that. And what happened on some of these ranches, and you've all heard these anecdotes, we've now got data to demonstrate it. The ranchers and the data we have documented that we've reperennialized streams that had gone intermittent and reperennialized base flow to streams and wetlands on landscapes that are using this sort of grazing. So remarkable recovery compared to what happens under continuous heavy graze or light graze. What was intriguing to me, and I kind of had a hunch we were going to find this, but I didn't know, and now we've got 20,000 data points, 28,000 data points. We can document that planted tame pastures, tall fescue, European brome grass, any number of species that are cool season grasses, about 90% of their root mass is in the upper 15 centimeters, and they don't pack the soil organic carbon into the ground, and they don't support the improvement in the water cycle. So the cover really matters. It's not just that all green is green and all green is equal. As in comparison to that, so what you're looking at is a meter depth profile with the soil organic carbon in a planted grassland and in a restored grassland that's warm season grasses, and just substantially different carbon distributions and carbon quantities being packed into the soil. The best pastures that were really productive and had the highest, the other thing we've done, and I'm not reporting it, is we looked at the nutrient chemistry of the plant materials of the soils, and with Alan Williams and a number of other folks, we're looking at the quality of the meat, looking at rancher well-being and animal well-being. It's a very comprehensive approach. What I can tell you is the quality of the food quality, the food density, nutrient density, I guess is what Alan and others call it, and the fatty acid profiles of the food coming off these native prairies is substantially different, or restored prairies, not necessarily native prairies. So the native plants drive to saturation in the upper 15 to 40 centimeters of the soil, and then they just pound organic carbon at depth, in some cases far deeper than the meter deep that we sampled. So what's really interesting is in the reconnaissance sampling and the actual detailed sampling that we've done, in all cases we've exceeded 1% improvement over the sampling periods, which suggests that little idea about adding 1 ton per acre per year of organic carbon is absolutely doable. So the real issue is scaling. How do we get landowners involved to rapidly scale? A lot of grasslands and a lot of croplands on the planet to do this work on. This produced here at the University of Wisconsin, this map. Oopsie. So we published a paper in the Journal of Soil and Water Conservation, which is apparently the most downloaded paper ever in that journal's history, which kind of amazed me. And it really did a back of the envelope projection of what the benefits would be with, currently IPCC is suggesting reduce ruminants on the planet. And some of the reports are suggesting by 50%. So reduce cattle and goats and all the animals that we all call ruminants. And what we've learned is that there would be very little change on a planetary level with regard to methane emissions, nitrous oxide emissions, and CO2 emissions if that was done, all other things being equal. As soon as we start converting agricultural, row crop agricultural land to alternative approaches, and I'll give you an approach in the next example here called low disturbance cropping. It's one pass no-till with 1 to 2% soil disruption. And if you convert to that technique with cover cropping and crop residue management that I'll talk about, and you convert 25% of the pasture base on the planet to this AMP grazing, there's an immediate shift toward global improvement, a reduction in legacy atmospheric levels of all the greenhouse gases. And then the hypothetical, all this is very hypothetical because it all involves landowner involvement and engagement. But you can see, based on the work we did with Shell, that it looks like there is real promise in thinking very big and taking to scale ag and alternative grazing at landscapes. So here's a map of all the AMP grazers we're working with. And this doesn't include the western US. This is just the south, southeast, and Canada. There's over 5 million acres of ranchers included in that. And there's neighbors converting to AMP grazing. It's a very quickly changing environment in the ranching community, but it depends upon where you're at. In some locations, nobody wants any part of this change, and in other locations, there's rapid transition occurring. The other project I wanted to share with you is an example of an alternative group of farmers that actually a group of farmers that are, well, they are alternative farmers too. Alternative farmers thinking differently and doing differently. And it involves one of the most highly erodible landscapes on the planet, the Palouse area of Washington State. It's about 30 million acres of land. Our study is focused on our carbon project that we're going to do is focused on about 7 million acres. The first thing we did is we learned that USDA and the marketplaces engaged in carbon had no standard method that everybody could agree to on how to measure carbon repeatedly in a reliable way at landscape scales. The marketplace doesn't use the same language. The carbon marketplace doesn't use the same language that the USDA scientists use, so we had a huge disconnect. So a group of us with angel investors invested about 3 years and $400,000 and wrote a new method. And the new method is available on the Verified Carbon Standard. You could look it up, it's all public. It basically involves 20 modules that provide a standard way to measure all carbon and all greenhouse gas emissions coming from all conservation and all agricultural lands, including forested lands, but our method hasn't been approved for forested lands because there's other methods that focus just on that. The only thing we didn't focus on was wetland systems. How do you reliably measure soil organic carbon dynamics in wetlands that have expandable and contractible soils? So you need a way to provide a vertical reference point so that you always know you're measuring the same volume. We applied that method at the scale of 30 million acres and then figured out that we were crazy working at that scale because there was so much heterogeneity, and we boiled it down to 7 million acres, and we're still crazy working at that scale. But we're able to do it statistically. So the first thing we did was stratify the landscape, so biophysical stratification, depth to groundwater, depth to bedrock, the mineralogy of the soil, the texture of the soil, the history of the soil, or of the farming, each of the farms that we looked at, slope aspect, topography, a range of other, I think there were 23 variables that we looked at and mapped. And then the other thing we did was pre-sampling to actually look at where soil carbon was distributed on the landscape. So over the hills and dales, and did statistical sampling. This process allowed us to identify that there were 3 primary variables that were determining the quantity and presence of soil carbon on this landscape. It was the precipitation zone, so moisture availability basically. It was the slope position on the landscape, and it was the aspect. Those were the three highest. They accounted for like 97% of the variability on the landscape. So we went to the landscape and looked at conventional tillage and cropping land and allocated samples randomly on farms that we had access to doing conventional, and then farms that had converted to low disturbance cropping, which is this one pass no-till, that converted 1 to 5 years ago, 6 to 12, 13 to 20, 21 years and greater. And then we picked up CRP land, some irrigated land, and we picked up all the reference natural areas that we could sample, all the Palouse grasslands that are still present. And we began this process of, here's a typical 5,000 acre farm. It's kind of hard to see it, but the little dots are the random points. We went out with a GPS unit, drove to the GPS points, the randomized points, with his Giddings soil sampling unit and collected the 1 meter deep samples. Brought that back and did the analysis of soil carbon through depth. The goal for the farmers here is to figure out how to improve their soil health, with soil carbon being part of that. And they realized the importance of continuous cover. So a group called Shepherd's Grain that produces very high protein, very high quality flour for pastry and pizza, they said, we're committed to 100% cover year round. We're committed to 100% crop residue, or as close to that as possible. If we don't have cover, it's crop residue. That's living cover or crop residue. And the goal we brought to them was, well, how can we incentivize you and your neighbors to think about actually innovating even further? What would it take for your 100,000 acres to leverage 5 million acres? What would it take to bring your neighbors into this? And we began looking at what's actually happening in the area. The soil carbon levels in all of the conventional farms, those particularly using conservation tillage, are losing about 2.02 tons of carbon dioxide equivalent per hectare per year. That downward line is what's happening under the, what was thought until just a few years ago to be the best soil management practice in the region, which was conservation tillage takes the form of chisel plowing and ridge till farming and a number of different methods in this region. What we've been able to demonstrate is a normal 2 and 3 pass no-till is even in some soil settings losing organic carbon, which I didn't understand until we measured it. What we're finding is this low disturbance cropping, which retains 80 to 90% of the residue and has 100% cover on the ground, dead or alive cover, year round, is actually pounding about 50% more organic carbon into the soil than the best 2 to 3 pass no-tillers in the area. So all the thinking that I thought no-till was perfect, but what I'm learning is that the devil's in the details, and I should have known that. I'm just not smart enough to realize that the same piece of equipment operated differently and operated on land that has a difference in the way it's been farmed for years produces different results. So standardizing, not all no-till is the same, is what I'm trying to tell you, if that makes sense. So what we did is we prepared this poster and went to the Pacific Northwest Direct Seeding Association conference, which brings in 10 or 15,000 of these direct seeders. They don't even use the word no-till in the way they're languaging. And we told them, 2 to 3 tons of carbon per hectare per year in the green areas where the rainfall is greater than 16 inches, and less than that in the yellow areas where the rainfall is less than that. And we signed up 300,000 acres of farmers, and we've now got about 100,000 acres under 20-year a program where we're able to represent their interests in the nascent, immature, non-existent carbon marketplace. I wanted to give you a couple local examples where cover has been part of really, really high-performing conservation projects. So here's a wonderful project we had the honor and pleasure of working on with the Nature Conservancy in northwestern Indiana, where they came in and bought 2% of a county. The whole project is based on, in part, the history of hydrologic change at a landscape scale. And this is data from another publication. What we've been able to document from the mid-1800s to the present day is that the amount of water leaving the landscapes in the Midwestern region is increasing, even to this day, with the best management practices in place, with detention ponds in urban areas, cover crops on landscapes. The amount of water leaving the landscapes is increasing. So these are linear regressions. The low flows, this is for the Des Plaines River, a 620 square mile, 400,000 acre watershed. It's in southeastern Wisconsin, headwaters in that area, and then goes down through Illinois and confluences with the Kankakee and becomes the Illinois River. What's happening over time in most of the rivers in our area is that low flows have increased significantly. In the Des Plaines River, the low flows have increased by 250 times over historic levels in the 1800s. The median flows, the 50th percentile, have gone up by as much as 400 times from historic levels. And the high flows, which I was surprised by, have only gone up about 1.5 times compared to historic high flow flood events. So the process from pre-settlement grasslands, prairies, savannas, wetlands, through a tiled and ditched agricultural era, through, in this watershed, suburban and urbanization that's occurred over large areas of the watershed, has resulted in these changes in flow. Well, what's happened, this is basically the fingerprint of annualization, of eliminating perennial landscapes and annualizing the landscape, or in more recent years, paving over the landscape. So there's, I'm not trying to make this more complicated than it is, but this is a fingerprint of that whole transition on that landscape. So what's happening is where we had a landscape that historically had a hydrograph with a predictable seasonal high water level, the highest level of discharge coming off of the landscape, usually at some point during the year, and a trajectory, and usually that was in the spring of the year, the high, and a trajectory toward a seasonal low. This is what we've called nature's hydrograph. All ecosystems on the planet except estuarine systems that go through a twice diurnal change. All other ecosystems that I'm aware of on the planet, from the tropics to the Arctic to our wonderful Midwestern area, had this historic hydrograph or something that looked like this. And this is what's coming off the land now, right here in Madison, and over most of the agricultural landscapes, certainly urban and suburban landscapes, predictably unpredictable hydraulic performance. That's great. That means that all these averages that we, normal water level and an average water level and a release rate from a detention pond that's an average, none of that makes any sense when you start looking at how these watersheds are performing. And it's really critical to understand that grassing and perennializing landscapes is really about restoring that nature's hydrograph. It's about putting stinginess back into the system. Landscapes and ecosystems that hang on to water and hang on to nutrients, instead of the exact opposite, the antithesis, which is what we create in our conventional ag and conventional urban settings. We've been able to document in some projects where we've installed nature's hydrograph using a different sort of stormwater management system. This is Mike Sands is here. This is the HSPF calibrated modeling from Prairie Crossing, a subdivision, a conservation development in Grays Lake, Illinois, where we, instead of building storm sewers and detention ponds, we built prairies and wetlands. In that project, the 100-year peak event has been reduced by 60 to 70% compared to a conventional development in the same soil type with receiving a 100-year storm event. So only using nature and restored landscapes has produced a very significant benefit, and I'll give you some sense of how important that is. So the Kankakee Sands project was predicated on restoring the hydrology over a large landscape. There were major ditch systems with legal encumbrances, about 30 to 40,000 lineal feet of tile per acre on average that was draining the ag land, and very, very light, low relief, 6 inches to a foot of relief over large landscapes. Nevertheless, we did a seed bank analysis, and we broke the property up into, I guess I do have a pointer. No, I don't have a pointer. Yeah, we do. We did a restoration plan, a phasing plan, brought the equipment in to hit the undo button on the ditches that we legally controlled. So we eliminated the ditches. The water came back up, surcharged up the tiles, and disabled the tiles when they were no longer self-scouring. And then we rented a Jesus Christ machine, which is what I call it. Sorry for my religious slur. A machine, a big auger fertilizer spreader with 200 foot of a boom width, and that would allow us to seed, rain down native and cover crop seeds over this property at a rate of an acre every 48 seconds. Very, very low cost, about $6 an acre all in costs. We hired local high school children. They're not children, I guess, high school sub-adults. Some of them are quite big nowadays, way too much protein in their diet. And we hired them, and with Nature Conservancy volunteers and other went to all the local native remnants, prairie and wetland and savanna remnants, and collected seed, very large quantities of seed for about 340 native plant species. And those were introduced onto this property. The site actually has been a wonderful educational location for thousands of sub-adults, adults, and sub-adults. And in essence, the property has been serving as a stepping stone because of the cover, because of the habitat for whooping crane reintroduction across North America. Oopsie. So here's a project. I think what's really important to understand is that the regrassing and reperennializing the landscape has all sorts of benefits. If you're a rancher, you're directly tied into some of those benefits. But here's an example of the economics at a much larger scale. This is the Red River of the North. It's got a 30 to 40 mile wide floodplain, and it doesn't take but 10 dogs urinating on the landscape for the whole watershed to flood. Big dogs, sort of real big dogs. Paul Bunyan dogs, yeah, or maybe blue oxes or something, I don't know. What they've been doing up there is building reservoirs to control the floodwater. The rainfall distribution is shown with the blue bars, the histograms. It's called the Hydrograph. The Hydrograph, which is the water discharge relationship from one reservoir. I don't know if you can see it, but I think Jaws, the big shark, would be frightened if it ran into something with teeth that pointy and sharp. The Hydrograph shows a bounce of several feet, more than several feet in this reservoir, and then quickly the water comes back down in this reservoir. We've been part of a national science team that said, wow, these reservoirs aren't working too well, they're outrageously expensive. You got to build 30-foot high dikes that go around 10 square miles, 20 square miles. Why not restore wetlands? Why not restore grasslands? So here's the exact same storm event plus a second event of a 2-inch rainfall. The two, you probably can't see it from back there. And look what the Hydrograph does in response. The tributary areas to the reservoir and to the several square miles of grassland, wetland restoration are nearly identical, and the depressional storage in the reservoir and in the grassland are nearly identical. And you can't see the numbers from there, but there's about a 6-inch change over the course of about a 2-week period. The water slowly comes up, and then the water slowly goes back down to a pre-flood condition. And it turns out that there's hundreds of millions of dollars worth of flood storage and flood damage reduction value in the way these grasslands and wetlands are managing water. And there's not enough time to really give you an example right now, but there's a big city in the US that just had a major flood. I won't name the city, but it's in Texas. Yeah. And we have just finished up an economic analysis of the alternative to building reservoirs, and it looks like grassland restoration at very large scales provides trillions of dollars worth of value during the same lifetime of a reservoir life cycle, and costs significantly less to operate and maintain, and actually is productive. You can grow, stuff on it, yeah. So I think with that, Lori, I'm done, if that's great. Good enough.
That is good. Thank you so much. And we have time for a few questions. Does anybody have questions?
So, number one, thank you for talking hydrograph. That is something I think that so many conservationists disregard. They think floods come because 2 inches of rain fell.
Yep.
But thank you for that. My question, though, is based on the grazing component of your talk. I saw that you didn't include the arid west in your study. I'm trying to wrap my head around how that applies to those millions and millions of acres out there where you've got historically very little grazing on those landscapes. Now 200 years plus of intensive grazing, and feral horses on top of it all now, and incredible invasive infestations into these areas with cheatgrass and everything else.
Yep.
That when you take the grazing off, changes the fire regime.
Everybody hear Tracy? You all hear him in the back there? But I can try to repeat it. So the question is, what's that? But somebody, I think I saw a hand back there say they didn't hear him. You're good? Oh, okay, I'm sorry. So Tracy, our study does include the West, but right now what I showed in the mapping is the focus on 3 provinces in Canada, the Great Plains in the US, and the Southeast. That's what we're funded right now and working on. But we've got very large areas also in the study, from Texas through through Central California, Northern California, a lot of work in New Mexico. I think what we're learning is this adaptive multi-paddock grazing even works better in the West. And I wouldn't have thought that at first because of the lower rainfall and the infrequent, reliability of rainfall. Fire issues are a real threat. Cheatgrass and a whole range of other invasive plants, depending upon where you're at geographically, do carry fire and do, routinely represent a risk. We're learning that, I think we're learning that actually where this AMP grazing is being introduced, they manage the fuel and therefore fire better because they graze to a level and then allow a recovery period, and that recovery period usually is associated with green non-combustible material that replaces cheatgrass, for example. So you bring in agropyron Smith, western wheatgrasses, a whole series of the triple on western grasses, blue grama, black grama, the various species, and replace cheatgrass simply by intensified grazing and recovery. That's working on a couple of ranches that we've measured in New Mexico. Just in a period of 5 to 7 years, the seed bank of the native grasses, which was present, has exploded in a good way. It's recovered. What's not happening as quickly in the West is the organic carbon recovery isn't occurring as quickly. It looks like it's going to take longer than 10 years before we could reliably measure statistical differences under the changes in the grazing regimen. But the only thing I'm feeling uncomfortable about right now is the plant and insect and microbial diversity response. I'm not convinced if the seed bank is not present for natives, we won't see the native plant species recovery very quickly at all or at all. And we're not seeing, without the native plants, we're not seeing microbial recovery, mycorrhizal fungal recovery. So David Johnson at New Mexico State University and Michael Lehman at the ARS lab in Bismarck are focused on that, and Wendy Tahiri is focused on the mycorrhizal work. So we've got a really, one of the top-notch teams on the planet looking at that stuff. And I'm not confident that we understand that recovery potential right now in the West.
I think we're going to have to hold it there.
Only one question.
Yeah, well, we got to keep on schedule here. Steve, will you be around for the rest of the morning?
For a couple of hours, yeah.
Okay, so if others have questions, feel free to meet up with Steve. Our next speaker I'd like to introduce is Jacob Marty. He's a sixth-generation farmer, I believe, from southern Wisconsin, and he's here to tell his story about continuous living cover on his farm.
How about this? Sound good? All right. I'm going to take the same position as Steve. Where's the clicker here? All right. Let's try this. Okay. Again, I'm Jacob Marty. I'm from Monticello, Wisconsin. I was really excited when Keith asked me to come present because I love talking, and especially about myself. But he basically it was wide open. I asked him, what do you want me to talk about? Because I don't feel like I have any special amount of knowledge or expertise or experience. I'm only in my third season of farming or back on the farm. And he still said, whatever you want. And so I decided I want to talk about my relationship with my dad, because my dad and I are farming together, and we're transitioning from his and what he was doing for about 3.5 decades as the head of our farm. And in just 3 years, we had transitioned almost 90% of our farmland into continuous living cover. And what that has meant for him, for me, for our relationship, and for the community around us. So I really wanted to think, like yesterday we were talking a lot about the ins and outs and the current science and what we need to do. And I was just thinking, it's like, you need to have my dad come here and talk to you guys about what he felt, and maybe hire him to go out and talk to other farmers and tell them, this is why you should do this type of stuff. But you got me, so we're going to try it with this. But yes, I want to talk about generational dynamics from going from grain to grazing. So I always like to start out my speeches with my favorite quote, and something that got me started in this type of farming. And it's by Elder Leopold, and it's, "We reached the old wolf in time to watch a fierce green fire dying in her eyes. I realized then, and have known ever since, that there was something new to me in those eyes, something known only to her and to the mountain. I was young then and full of trigger itch. I thought that because fewer wolves meant more deer, that no wolves meant hunter's paradise. But after seeing the green fire die, I sensed that neither the wolf nor the mountain agreed with such a view." And I read that when I was in college, and it kind of sparked something I didn't know at the time, but it followed me along as I was in my education and traveling and trying to learn more and more. And I eventually came back to the farm, and I'll tell that story if I have enough time. So this is our farm, Greenfire Farm. From one of the high points, it's a 400-acre farm. About 300 acres are arable, not tillable. And this is from our first year, 2015. You can see there's a lot of corn still there. But I'm sixth-generation farm. My dad is the fifth generation. He bought it from my great uncle, who's here, great uncle Jake, who I'm named after. And then my grandpa was on the other side, Hank. And for about 3.5 decades, my dad ran the farm as a conventional row crop and dairy. Very successful, very financially stable. And then I decided I wanted to come back and change it. So I want you to notice here in the back how long this grass is, and it wasn't mowed. I'll come back to that later. So, but right now, we transitioned to mainly grass-fed beef using daily rotations, cow-calf to finish and direct market. We also, in our direct marketing, we raise pasture pork, 100% grass-fed lamb, and we also do laying hens and then meat birds too. So this is my father, Jim. This is our first pasture that we seeded down. Everything that we put into pasture was pretty much corn the previous year. So it was like, brown be gone. And so I knew that I wanted to use this picture in the future because he would think, but he was just like, oh, don't you like how nice and smooth and how well prepped that, like we should plant corn in it. And it's just, you can also notice he's funny, or he's happy, and he was feeling good. He was really excited to have me back on the farm. Things were really fresh and new. And I really want to talk about how our emotions have changed throughout this entire thing. So to get an idea of that, my dad is goofy. He's very successful. He's established. He's well respected in the community. People look up to him. He's a community leader. He's also very happy. He's a prankster. You got to watch your back and make sure that you're keeping an eye on where he's at, or he's going to scare you. He's also very anxious. He's gone through a lot in his farming career: droughts, financial hard times, hired men quitting and having to put in 120-hour weeks, that type of thing. He's anxious. He's always worried about what might go wrong. It's a good trait for a farmer. He also has a temper. Maybe that's just with me. I don't know. And he is very stubborn as well. He's Swiss. So, okay. And so just kind of keep that in mind as I talk about this. So this is me. I graduated from UW-Stevens Point. I went there and got a degree in wildlife conservation. I wanted to save endangered species, provide all the habitat in the world. And while I was there, I just kept on, where is this agriculture coming in? Why aren't we talking about providing habitat on agricultural land? And I asked some of my professors, and they're just like, well, you got to deal with farmers then. Yeah. And they're, yeah, and they're like, they won't listen to you anyways. They're stubborn. I'm like, I'm a farmer. I'm stubborn. I'm not accepting that answer. So I got to figure out how we can do this in agricultural lands, provide habitat. We got to do this. And so some honest reflection of what my emotion is. I'm idealistic. I think about the world. I discuss with people about the world, things that are going wrong, things that are going good, what we want. And because of that, I'm very idealistic, and I'm a millennial. And because of that, I'm frustrated and a little bit jaded when I look out at the world. Yesterday, I heard the thing is that we've been working on phosphorus in the dead zone for 20 years, and it's just not working. That really bugs me because I wasn't the one working on that for the last 20 years. And so I'm starting to work on it. It's like, we need to get going. I'm impatient. We need to get, I want to have kids maybe. So that's how I feel. And it just directly motivates me. I'm a self-starter. I look at those problems. I think, how can I fix those or at least influence and be part of the solution? And because of that, I convince myself that I'm very confident. And some of my friends say I'm bordering on arrogant. I guess that's just how I am. I did ask them, what exactly does arrogant mean? Because that doesn't really, you don't know that when you are that. And they said, don't worry, you're not that pretentious. So, but I'm also Swiss, and I'm like father like son, I'm stubborn. So you can see maybe that might be interesting how I deal with my dad. So my personal goals also affect it. You guys are talking about this continual living land cover. I love it. It's like, you're not convincing me. I'm all for it. But in my personal life, why did I choose farming? Well, I wanted a life where I had control over my own decisions. I wanted to be my own boss. I wanted to live outside. I wanted to act like, I wanted to know that I had a positive influence on the world. I wanted to protect landscapes. I told you I want to provide for endangered species, bring them back. I would love to live in a world with no endangered species. And I grew up in my community, people tell me, be a leader, be a leader. So I want to continue to be a leader. So I figured out farming could be my outlet for those personal life goals. And so on the farm, I thought about how do I want to raise animals, and reflecting back on being raised on this farm. I wanted to raise animals in a more humane way. I think they deserve sunshine, grass, fresh air, people not yelling at them. And then I want it to be sustainable. What's the point if I can't provide a land base that will help our family be on that land for another 6 generations? And biodiversity, can we have a farm that also provides for nature? Communities, we have to think about the human dimension. If we're affecting the other people, our neighbors, the people that are inside the community, our entire land base will be uplifted because more people are being empowered and thriving in a healthy community. So I wanted to give back to the community. I grew up, my community was so supportive of me, coaches, friends, parents, teachers, always just helping me with anything I needed. So I wanted to come back to the community, pay it forward, and give it back. And I want future generations, kids that are in school right now, to come back and follow what I did. Because sometimes it doesn't make sense because they think, the culture does not think that our small rural towns have that much to give compared to the big cities. So I remember sitting on the couch in my junior year of college, and before this I had never talked to my dad that I actually wanted to come back to the farm. I was thinking about these goals and talking to him, and I told him, I think I want to come back to the farm. He was elated because I have 3 brothers, none of us want to farm. He's like, he never knew what went wrong, and I could tell you that's another story about why we didn't want to farm. But I said, I kind of do want to come back to the farm, but I got to do this a different way. You got to let me try. So he said, let's go for it. So we came back to Greenfire Farm. Well, it was J&L Marty Farm, and Greenfire Farm is what I call it. So in 2015, about a month after I graduated, we bought a herd of 17 bred cow-calf pairs that were going to spring calf. Everything was brand new, exciting, but very uncertain. What's this going to be? I was telling him, it's going to work. It's going to work. Sustainable, profitable. We're going to love it. We're going to have so much free time, go on vacation. All this stuff. I was writing checks, my mom getting cash. So, but we started out with 50 acres. Again, we want 50-50 on ownership of these cattle. I said I provide a lot of the labor, and I also started out with 6 hogs, 12 laying hens, and I got about 100 second trees from like a nursery. And so what we started out was we planted a very diverse mix, and we're planning on doing rotational grazing. And then that's what it came up as. Very diverse, very lush. Cattle absolutely love it. And it went really, really well. And so well that I'm always trying to, okay, we got to get this land healed right away. 2016, okay, 5 minutes. Okay, we're going to go 40 more acres, and in 2017, we're off to the races. We put 160 acres of fence, the water line seeded down and started pasturing. Up to 200 head. We finished 80 fats. Going through this really quick. Everything's being scaled up. So these are some of the animals. We planted trees for a silvopasture. Here's pigs inside the alleys. Sheep. And we got laying hens too. So how do we do it? EQIP funding helped a lot and CSP, but we self-funded, no bank loans or anything like that, and direct marketing helped get a higher premium return. Existing infrastructure, we had dairy equipment, mixers, tractors, hay vines, all that type of stuff. We had buildings still there from the dairy. My dad has knowledge, and I knew cattle, but we knew how to make hay. We're really set up well. And my dad has wisdom, I do not. And help. This is something that is encouraging other people. And I have friends and family members that come and volunteer because they want to help it succeed. So again, let's think about, this is a big change for my dad. We started butting heads. And if you're going to think about the different ways that we view the world, again, I said, you don't have to convince me, but you have to convince my dad how to do this and people like him. We butted heads a lot. And just moving cattle, I'm slow, quiet, let the cows figure it out. My dad's clapping his hands, let's go, let's go, let's go. You should see us moving cattle together. And it just snowballs into yelling at each other. He's focused on yields, I'm focused on soil health. We've lost 6 to 12 inches noticeably from the fence rows on our farm. So anytime he says yields, and he's like, you got to get money there. I said, how much is your topsoil worth? Obvious and hidden costs, we both see different things that are like, you're spending money on this and losing money, and vice versa. Practicality versus aesthetics. This is something that really affects, like, I have a higher tolerance for mess, I guess. And not what my dad said, but one of a very respected farmers in the community drove past our new hay fields that were grazed on, and he told my dad, he goes, I just went up over that hill and saw those cattle on the hayfield. It just made me want to puke. He told that to my dad, and I was like, wow, well, I felt the same way about when I drove over your brown fields, but you can just see like the the pressure on my dad, people are not agreeing with what he's saying and thinking he's insane. And just how do we connect there? Starting time, I get up late. Let's leave it at that. So again, let's think about those emotions and the things that we have going on in our life and just the daily tribulations of being an entrepreneur or a farmer and what that means. So how did this affect us? Well, again, my dad really felt as this was a big change. He felt anxious, impatient, and still uncertain on a lot of things. We changed so much, and I was pretty confident on my things, and I was just like, God, trust me, Dad, we got to do this. So in a lot of ways, he felt criticized that the last 3.5 decades of his life have been doing it all wrong. When he knows he has money in the bank account, and other people in the community have been telling him that you've been farming the right way, you're a good farmer. Felt very criticized. Sometimes when I just said, I cannot go with that, felt disrespected. And it got so much to the point where he almost felt resentful that I was back. And he said that times, he goes, what if I just kicked you off? And I said, yeah, those are hard days. So my dad's very happy, but at the same time, he was able to be very miserable. Well, in the end, my dad did end up turning out really proud, impressed and surprised. This was perfect timing. Last week was at Thanksgiving, and he never tells me this type of stuff, but he tells my uncle. My uncle sits down and he goes, Dad said you guys just sold 40 cattle, and it went really well this year. And he told me, if I would have known that when I was his age, I would have done this all back then. It was so easy. I was like, did he get it on tape? But at the same time, I felt like I was butting heads with my dad. I was obviously always supportive. He was always there to help me, all that type of stuff. But emotionally and mentally, sometimes I did not feel support. I felt just as criticized, and that the way that I wanted to do things, that I wasn't intelligent enough or hardworking enough, or I wasn't getting up early enough and putting in enough hours like he did. Just never live up to your dad's expectations. And sometimes I felt uncertain, lonely, but really I was proud and supported as well. So I think I can go into the lessons some other time afterwards. They're not as important, but you just got to keep these emotions in mind, thinking when we talk to these farmers that have been doing things a certain way, that they are very strong, but they can be very fragile and sensitive at the same time, and they do not have a culture within themselves that support going through hard times. It's very independent. They don't like to talk about it. And when you try to reach younger generations and tell them that they should be doing this, we're really putting those family dynamics in crosshairs into a really difficult situation. And so we need to be sensitive to that and help them through that and be honest about what you're going to go through. Okay. So again, I just want to say we could be force of nature. We can bring animals back. I've seen woodcocks, bobolinks, minnows for the first time on my farm my entire life. And everyone can do this. So I'll stop there because I'm over my time, I think. So, but thank you very much. Do we have time?
So actually, Jacob was so efficient, we have time for a question or two. Who has a question?
Oh, these ones? Yeah. Yeah, I really wanted to capitalize on this. I was upset that I didn't get to this slide, but we have the potential to be forces of nature, not in the sense that we can destruct the world and have this just leave demolition behind us, but we can be a force to be reckoned with on behalf of nature, and we can bring animals and bring those diversity back. We have thousands of voles coming back to the farm with just ground cover, and I'm sure that the snakes, the fox, and all the other higher levels of the food pyramid and are going to come back right after. It's really exciting to see. So, yeah.
One more. I'd like to see your lessons learned. Can you go over
Sure.
the lessons learned?
Yeah.
Lessons learned.
So,
Skip that slide.
Yeah. See, I like talking about myself too much. Okay. So, communication is extremely important. My dad and I did not both of our styles are not to meet and talk this out because we just get derailed and we start maybe yelling at each other or I don't know. So we're just both kind of had separate goals and we're never able to share those with each other. And it gets to a certain point, if you don't know someone's name and you haven't they keep saying, hey, you get to the point you can't be like, what's your name? And it was like that with goal setting. It was like we're just both on different trajectories, but I mean, I was just pulling my dad as anchor along in a sense. And we never shared our vision, even though I'm sure our visions align. So that's one of the first things you should do. Patience and empathy, to just think about, like, step back and think about the person you're farming with and how they see the world, and just think about, okay, these actions on the farm, what that could mean. Grace and independence is really important, and it's one of the things that really started making me struggle on the farm with my relationship with my dad. I needed room to make my own mistakes and to go through things. It's just, that's maybe a father-son thing with anyone, but I needed space to make my own mistakes. But I also needed to have, looking back, I need to have the grace to be able to accept advice too. And when you're getting older generation, my dad was like, we were talking about yesterday, hip replacement, both his shoulders are shot, and he still works through stuff. He does not like to have a whole lot more extra work put on his plate. So if you can recruit friends or family to come in and help you out on the weekends and stuff like that, rather than put it on the older generation, keep that work burden down. That's very helpful. Yeah, those are the most important things there. So.
All right. Well, thank you, Jacob. So our last speaker is Chris Kucharik, who's a professor in the agronomy department, and he's done some modeling work, and he's going to bring us back to the Yahara watershed and some of their work on modeling into the future and how continuous cover plays into that.
So while Laura's getting my talk up there, I didn't realize you had to be a comedian to be a part of this plenary this morning. So great talk, Jacob and Steve. This is going to be a little bit of more of a depressing talk, probably. I'll just lay that out right now. Some of you probably heard Randy Jackson speak yesterday. I heard he gave a really provocative talk, which is good. I'll touch upon some of his ideas about perennialization. And I'm also different as I'm going to stand on this side, so I'm left-handed. So what I'm going to try to do in the next half an hour is summarize the culmination of about 6 years of work on a project that was funded by the National Science Foundation. And I just want to give credit to a whole host of other team players here, some of which you might know by name here. We looked at plausible pathways to sustainability in the watershed, and I'm going to focus on the water quality question here this morning and not so much on the other ecosystem services that we were interested in. So just to orientate you, you're sitting in the Yahara watershed. You've got Lake Mendota to your north there. We're obviously a part of the Mississippi Basin. So the water that goes through our watershed makes it through to the Rock River, which makes it to the Mississippi. So things we do here have a connection to the Gulf of Mexico and things like hypoxia and dead zones, which you might be familiar with. This area was heavily influenced by glaciation, but you don't have to drive very far to get into the driftless area, obviously, of southwest Wisconsin. We're an urbanizing agricultural watershed. About 50% of our watershed is agriculture, denoted by a lot of the yellow colors here, with a dominance of dairy farming here in the north. Obviously, the elephant in the room with us here is non-point source pollution, unfortunately. We have seen a significant amount of phosphorus loading into our waterways here. I'm just showing a graph of annual phosphorus load measured at 2 points in the watershed on the Yahara River as well as Pheasant Branch. And the thing that you'll notice is that over the last 40 years or so, we've seen no decline in the amount of phosphorus loading into our lakes. And this is on top of having 40 years plus of better management practices being implemented. Lots of effort, lots of money going in, lots of studies to try to figure out, well, how do we transition this watershed and lakes from eutrophic into a better water state. On top of that, we've also had an increase frequency of extreme rainfall events. Since the 1950s, we've seen climate change. That can be quickly summarized here. Generally, over the last 80 years or so, this area is receiving about 4 to 6 inches more rainfall than it did at the beginning of the period. That's equivalent to about 1 extra summer month of precip every year. But the more telling story is the number of heavy rainfall events. This is decadal totals of 2 and 3 inch rainfalls. So just in the last 2 decades, we've seen a doubling to tripling of the number of 2 or 3 inch rainfall events. And some of you might be, even aware of this in your own workings and maybe in your personal life. I think the statistic is, from my memory, 6 or 7 of the top 24-hour rainfall events at the Madison airport have occurred since the year 2000. So, and this trend is what global circulation models, global climate models project will continue to play out in the next 50 to 100 years, unfortunately. So one good thing to think about is that in the absence of BMPs, with climate change superimposed on top of intensification of ag in this watershed, these lines may have been trending upward. So it's plausible that the BMPs and things that have been going on have been able to tote the line, and we're sort of on a treadmill right now. Those things are able to keep up with changing climate, but as climate continues to change, the effects of those things and practices might start to wear themselves out and might not be as effective in a different climate regime. So some things that we should lay out here at the beginning is that there's been a 50% reduction goal in phosphorus loading since the early 1980s in this watershed. And despite the monumental planning and efforts of improved land management, we've been able to meet that goal. We're dealing with legacy buildup of soil phosphorus, obviously climate change. There's been changes in the lake food web in terms of invasive species that have made it more difficult to control algal blooms. Human demands and agriculture have both changed, and this is causing us to really underestimate the time, money, and effort that it's going to take to reduce that loading and improve the water quality in our region and to reach that goal. So it's really a result of shifting drivers. We would have expected that with management interventions that nutrient loading would be going down. But this comes with the assumption that things like climate, precip, and land use intensity remain static through time. But in reality, what's actually been happening is that we've seen changing climate, we've seen intensity in terms of land use going up. So we've been implementing those practices, but they haven't been having much of an effect and has been sort of causing this static nature of the nutrient loading. So the question is, what can we do? I know Randy laid out probably an idea of perennializing 100% of the landscape, which is maybe an option, but maybe a pipe dream also at the same time. So what are some of the compensatory land use management changes that we can use to improve water quality in the watershed as climate and human demands change? And the approach that we took in this project, and this is just one component of the project I'm talking about, is to use scenarios of change out to the year 2070, coupled with numerical modeling, some sophisticated biophysical and hydrologic modeling tools that connect storylines of the future to actual quantitative results that policy decision makers can use. So we have a lot of data about obviously what's been going on in the watershed, and those observations can tell us something about the past and present, but the use of models and scenarios can allow us to test hypotheses, to sort of play out experiments that we can't do over at the whole watershed scale, and explore future outcomes at a scale that's relevant to policy decision making. And it's the long-term thinking that's really needed to understand and manage ecosystems with a goal of increasing sustainability and resiliency of the landscape. So what actually are scenarios? They're meant to be provocative, plausible stories about the future with contrasting social and environmental conditions. They explore questions of what if, facilitate long-term thinking, and help us learn ways to prepare for and to cope with change. In this project, we specifically developed these integrative storylines of the future by going out and in the initial stages of the project talking to sort of the big thinkers and players in the watershed through an interview process to get their ideas of what are your concerns, what do you think are some possibilities of what the future might look like, to generate their ideas about opportunities and challenges in the future. So we wanted to gauge perceptions of land use, climate, water quality, and governance moving forward. After those interviews were completed, we brought teams of, or groups of those people together in 4 workshops of about 12 to 15 people each. We gauged sort of some common themes, and we organized that into 4 particular storylines of the future. So we basically sampled their perspectives, clustered them, and condensed into 4 scenarios. So these scenarios are I think they're provocative. And in fact, some of the ideas I thought were quite crazy when we were coming up with them. But that's the whole intent. It's to get people out of their comfort zone and to be thinking a lot differently about what the future might hold. So by name, these 4 scenarios are called nested watersheds, abandonment and renewal, accelerated innovation, and connected communities. And each is based on a set of human choices and biophysical events that shape the story. So they're written as short science fiction literature. And the idea is that the science fiction comes in by how the events are stitched together. In each of the scenarios, they're all based on elements of truth. It's just that we've amplified the events and accelerated how they sort of push forward towards the future. So they're all based on elements of truth. It's just how we stitch those things together is what creates the fiction. So in nested watersheds, there is a change or an adaptation by the government to maintain nature's benefits moving forward. And the idea here is that we get rid of political boundaries and start using water and sort of farming it as a crop or something that actually has value. In abandonment and renewal, there's a transformation of the watershed. Basically, there's inaction of government. Basically, people think that climate change is a hoax. We roll back environmental regulations. Maybe these things aren't that hard to think about in terms of what might happen, given the current state of our government. But there's a disaster that strikes, decreases the population, leads to a reorganization on the landscape for those that remain here. Accelerated innovation highlights the role of technology and massive growth in businesses, including green tech, to solve our environmental problems. And then lastly, connected communities, which we like to refer to as the Nelson Institute for Environmental Studies scenario. This is where there's a global shift towards values of sustainability. And generally, the key factor in change there is obviously values on the planet. So each of the scenarios has obviously a qualitative nature to it. It has characters. I encourage you to visit the website, which I'll have at the end of the talk, to read the stories and sort of engage and understand how things play out. But superimposed on that, each of those scenarios has a change in climate related to precipitation as well as temperature. And you can see there's a range in how the annual mean temperature warms. These are loosely based on IPCC scenarios of climate change. And then each of those has a change in land cover, decade by decade. I'm just picking out the abandonment and renewal scenario here. There's also changes in nutrients and animals, livestock, people's values, and those all go into driving these models that we use, which I'll get to describing in a minute. So just in a nutshell, again, accelerated innovation is if we prioritize technology to solve water and climate challenges. And I want to mention that during this project, we had a nice collaboration with a local artist, John Miller, who actually read the stories and portrayed the images in sort of a collection of imagery and paintings and things that he did. Abandonment and renewal, what if we're not prepared for water and climate challenges? And the last 2 I want to focus on because they're related most closely to the theme that we're talking about this morning with continuous cover because of the changes that happen on the landscape in these 2. So And nested watersheds, again, what if we reform how we govern to address water and climate challenges? So you can see, like, instead of states having sort of reign over what water rules might be, we move to a large watershed model of how things would be governed. And the next slide will show you how the land cover is changing year by year through the scenarios. Now you'll see a shift from yellows to shades of green, which denote an increase in the amount of land area covered by hay and grass for biofuel support. So bioenergy and cellulosic bioenergy is a predominant theme in some of these scenarios. So in nested watersheds, the water quality and food policy drive changes away from row crop ag towards biofuels, forests, and wetlands. Our urban density increases, so urban sprawl kind of goes away. We're just sort of building up instead of building out. And so you can see in this scenario, we go from a very small percentage of the watershed area covered by hay and grass for biofuels to about 20% by the year 2070. So there's a gradual rollout and increase in that land cover type. In connected communities, again, if we shift our values in response to our water and climate challenges, this again is showing sort of the changes year by year across the landscape. This is one that you might be most particularly interested in because it's the scenario that increases land covered by pasture from a small percentage early on up to 15% by the end of the scenario. So in the storyline here is that our diets shift away from meat and dairy towards vegetables, fruits, legumes, and small grains. The remaining meat and dairy is largely pasture fed. And then a lot of urban open space is converted to prairie and forest. So there's a transition more to a natural landscape here. But keep in mind, it's only getting up to the sort of this 15% coverage level across the landscape. So the idea from that point is we've got all these drivers. We need to translate those storylines into quantitative model driver information that we can use to get quantitative output that policy decision makers will pay attention to. I'm not going to go through the details of the biophysical modeling approach, but it's a collection of models that actually grow the crops and handle the cycling of carbon, water, energy, and nutrients through the landscape. Runoff from the landscape gets routed through a hydrologic routing model, which basically takes the river and stream network and routes that runoff through to the lake. So we understand how changes on the landscape translate into improvements or declines in water quality, which is modeled by Steve Carpenter's Yahara Lake's water quality model. So those three models had never been joined together before this project and give us a very powerful tool to understand if we do X, Y, and Z in the landscape, how does that translate into water quality right out the window here in the long term? So here's one of the key results. This graph is showing the total amount of phosphorus leaving the landscape as a total watershed average from the current period through 2070. This line here represents the current state of loading. So what do you immediately notice from the scenarios? Things get worse before they start to get better. And why do they get worse? They get worse because climate continues to change. Before we have a chance to really roll out those scenarios of better landscapes to help prevent erosion and phosphorus leaving the landscape. So it takes several decades for that transition to take place. And by the time we get out to 2050, 2060, 2070, then land management starts to overwhelm the climate change system and we start to see a reduction in the loading to the landscape. But granted, there's a whole variety of answers here. There's about a 15 to 50% reduction in P-loading to the lakes, depending on which one of those scenarios you choose. So while those scenarios point to rather modest changes in perennials and grasses planted on the landscape, simultaneously we're also looking at changes in the amount of fertilizer that's being applied to the landscape. So all the scenarios show a general decline, upwards of about 50% reduction in nutrients going on to the land that remains in row crop agriculture. So, but there are obviously a difference in the amounts, all the way from maybe upwards of a 30% reduction to almost 100% reduction in abandonment renewal. So that has an impact on the amount of total, phosphorus that's going out on the landscape. So it doesn't completely, there's not a complete elimination of phosphorus in any of the scenarios, but there's a reduction. And that's why we see a varying amount of reduction in phosphorus loading and leaving the landscape. So some of the things, that we're finding out, initially through this work is that climate change is going to greatly challenge our ability moving forward to reduce phosphorus loading. We think things are going to get worse before they can get better. The scenarios suggest, this varying level of reduction in lake P load. There's modest increases in perennials in our scenarios that get gradually phased in, plus reductions in nitrogen and phosphorus to the remaining row crops. And these point to gradual improvements in the amount of phosphorus loss. But we have this soil phosphorus legacy problem to overcome. Over generations of farming, the buildup of soil phosphorus, it's really hard to mine that completely out given the state of what we're doing currently. The other thing is that 50% of the phosphorus we're finding is in dissolved form. So I think some of the issues we're seeing with better management practices that are stopping the erosion and stopping sediment moving, the phosphorus moving in sediment form, is that we're not really accounting and able to deal with the other 50% that's in dissolved form. So if there's anyone in the room that can figure out how to keep water from moving across the landscape, you're going to be very popular. That's just going to be a problem we're going to have to deal with and try to figure out ways around that in the meantime. So as part of continuing work on this project, we thought about pushing the scenarios even further forward. So that this means instead of just the 10 or 15% change in perennials, what if we changed 25% or 50%? We didn't do the Randy Jackson blowout scenario of 100% perennials yet, but we could very well do that. And this is work that Tracy Campbell is doing as part of her master's work, and she has a poster on this particular topic. So if we do immediate rollout scenarios like today, we convert the landscape and not this sort of gradual transition that I just showed you in the scenarios, what can we expect? Well, if we just look at some of the colored lines, so the colored lines represent no change, 10% perennialization, 25 and 50%, plus a reduction of the same percent in nutrients applied to the landscape. So 10% means 10% more perennials, 10% reduction in nutrients on the remaining cropland. We can see that we can get pretty quick, results if we are able to do something like that. And if we combine the effects of the perennialization plus the reduction in nutrients, if we just look at the 50% sort of goal there, we can achieve a 50% reduction in phosphorus yield by doing those things. And we can do them more quickly if we can roll these things out more quickly. Now this is for current climate. So if we go to a future climate, which is very plausible, this is what happens. So we're challenged more on the phosphorus yield here. You can see that we go from there to there, and we can see that it's taking more time to reach that 50% reduction goal. And the same in terms of the total amount of phosphorus yield. So basically these 10 and 25% sort of playing out in the landscapes really are not going to do enough for us to reach, a 50% reduction goal that we have in the watershed. You might think of it as maybe a 50% by 2050 sort of plan, that you need to probably get 50% perennialization, 50% reduction of nutrients applied to the rest of the row crop landscape to get a 50% reduction by, let's say, 2050. That seems like, it's doable, but the sooner we start, the better likelihood we'll have to reach that goal. So what are some of the take-home messages here? So the modeling scenarios suggest we can get improvements. Incorporation of perennial cover, much greater than 25% is going to be needed. These are stopgaps that may sound really good to maybe policy decision makers, and they think, oh, well, that's a pretty sizable amount. It's not going to be enough. I think Randy's not too far off base in terms of what 100% could do ultimately. And perennial cover plus reducing nutrient reductions to row crops, I feel, if you can transition that slowly, it's going to have bigger bang for your buck. If we just do perennials without really doing much to the row crops, there's going to be a disproportionate amount of nutrient loading coming from the remaining row crops that'll probably overwhelm the benefits from the perennialization on the landscape. And that the changes can be slow, and that future planning definitely needs to account for the impacts of climate change. And that the longer we wait, the longer it's going to take to see significant improvements. So the last point I want to make is that this is all focused on water quality. There's another whole host of other ecosystem services that society needs to be thinking about as we move forward. And some of those would be, the biofuel production, flood regulation, freshwater supply, and then the big elephant in the room is food production. If we perennialize the complete landscape, how are we going to satisfy all the needs? And obviously there's no ideal scenario. We've got to be thinking about what do we want and need watersheds to provide moving forward, as well as what choices are going to increase the resiliency. So I look at it this way: what shocks are people going to have to deal with in terms of land use and land management change, as well as governance and policy, to overcome the problem in a much shorter period of time? I don't think people are willing to wait 50 to 100 years to improve the water quality as well as other ecosystem services in these watersheds. So how will we get there? How can we better support farmers through that type of transition? And how long might a transition like that end up taking? Those are some of the key questions that I see. And I would encourage you to visit the project website. Obviously, in only 20 or 30 minutes, I can't give you a full set of details on everything that we did, but that's the website. And I will stop there and take any questions if we have a bit of time. Thanks.
Yes, we started. We started about 5 minutes late, so I'm giving us a little bit of extra time, and we'll just have to cut into the break. But please do some questions.
You mentioned that we have to think of a way to stop water moving across the landscape. Mm-hmm. One of the proposed benefits or supposed benefits of perennialization is that water will then infiltrate. Yeah. And do the models start to take that into consideration and how that might affect the P-loading?
Yeah, absolutely. So the connection between the biophysical terrestrial model and the hydrologic model is the base flow. Okay, so there is infiltration, there is base flow moving, that's all accounted for. I would say, though, that a shortcoming of the modeling is related to some types of things that Steve had just talked about to start this plenary off, and how do we know sort of how that organic matter buildup is really going to take place, and will it be sustained through the future, and how will that differ depending on what grasses you're planting and types of landscapes that we put in. So I don't feel we have enough data yet to, with 100% confidence, parameterize the models to account for that. But it's in there right now in a generic sort of sense. Yeah. I'm sorry, who's got the mic? Who's that?
I was curious what the response of the agricultural community's been to your work or to this work.
Yeah, it's been mixed. I'll say that there's some people that aren't happy, that I guess in the way that maybe they were portrayed, or sort of how the outcomes of the scenarios sort of paint their contribution to the problem, and we're talking with them and sort of smoothing over those rough edges, and sort of through the efforts of, where's Pam and others who might be in the room, of getting a group together around the table that's probably never been put together before, that includes Yahara Pride farmers, scientists from USGS, us from this team, and other people from the university, to start talking about sort of how do we move forward and solve these problems. Yeah. I think right behind you, Pam, she's had her hand up too.
Thanks, Marie. Thank you, Chris, for the presentation. This is the first time I think I've heard so clearly this idea of 50% perennials by 2050 as kind of a what we need to do to achieve these reductions that's we've had for 40 years.
Yeah.
How is that, have you been able to share that with national policymakers or any other policymakers? It feels like that vision, Chris, in the ag community, we're still on the BMP mindset and NRCS, practices. So what, can you speak to that a little bit?
Yeah. Yeah, so I warned Tracy, who's my grad student, right before this is the first time I've said that in public, because I was really staring at her new modeling results for her project as well as the previous ones and starting to put things together and realize that there is an embedded message there that I think could be shaped and molded into something that could be kind of catchy, like we have our energy goals and that. So I think I'll work on that and sort of get to messaging that a little bit better and definitely get Tracy's work published first. But that's kind of, we'll follow up with more scenarios. And, the thing with a nice set of modeling tools, too, is that we can play out a whole variety of different ideas that you've heard me, sort of pitch over the coming years, too. So thanks for picking up on that. Yeah.
Okay, so my question is about, you talked about soil legacy phosphorus.
Yeah.
Dane County piloted a project last year where we dredged some of the streams coming in,
Yeah.
and they're finding tremendous loads in the streams. So I guess my question is that in the model? And then maybe you can perennialize all you want, but if you still have mass amounts of load coming in from every stream into the lakes until we dredge I know they put a bunch of money into it, but that could be a huge kind of hiccup.
Yeah. Yeah, so the first question, it is in our models. So the problem, though, that we have, again, is the amount of available data to parameterize the models. Like, we don't really know, like, how much phosphorus is stored in all these stream and river network channels. So the work that the county's doing is giving us some new, information and how old it is and so on and so forth. But then the question is, well, if we do that now, just to one area, like you said, will it compensate for other places? And then how long will it be before we have to do that again? That would be my concern. And is Joe Parisi's not in the room, is he? Are there better ways to spend that money rather than doing what we did?
I know they have it all segmented out, so they know it's been reduced.
Yeah, right. Yeah, that's a great question. Yeah.
Do one more question up here, and then we'll have to wrap up for the break.
Thanks. It occurred to me that Detroit, Michigan is a real live example of abandonment and renewal that might be useful.
Yeah.
Is this on?
Go ahead, Tom.
Go ahead. And then particularly on Ken's question about was ag in the room and that sort of thing. I think, so I work a lot in the urban environment, and equity is the issue always.
Mm-hmm.
And so we're forced in this new world for new groups to come together to talk. We're forced to get together new civic engagement kinds of ways. It's really uncomfortable. I think we're just all going to have to get really used to being uncomfortable almost all the time.
Yeah.
Comfortable.
Yeah. You're exactly right. I think and Randy and I have talked about this quite a bit with other colleagues, that the model and the way that this type of research is being done at the university and getting it out in landscape, like, we need a different approach to doing it. There's a lot of great stuff going on, not just here, but at other universities that I don't feel like ever makes it to see the light of day or is part of the policy decision-making process. And I think it's because scientists notoriously are conservative and afraid to sort of, as you say, mix it up and be uncomfortable. And but I think you're exactly right. That's what's needed, moving forward. Yeah.
We have one more person who's dying to ask a question.
I bet everybody in here, I want to have confidence that you're a voter, but when I see government up there, like government's a different entity, I'm a Dane County supervisor, and I talk to people, and when they're motivated, but when they say they don't vote, that is so discouraging, because we are the government, and you're only the government that you get, particularly if you don't vote. So, again, I have faith your voters, get out there and get more voters, because we are certainly seeing the consequences of the people who are voted into office, particularly at the national level. Thank you for letting us do that.
Okay. Okay, the last comment was, everybody who cares about this, vote. Okay, and I'd just like to say I think that we had 3 wonderful, fascinating presentations that we could have taken the whole morning on to have enough time for questions and answers. But we're going to wrap up now, and I'd like us to give all of our speakers another round of applause.